Welcome to our video on construction technologies that are revolutionizing the way we build and shape our world. Construction is an industry that has continuously evolved with advancements in technology. From traditional methods to cutting-edge innovations, new technologies are making construction safer, more efficient, and more sustainable than ever before. In this video, we will explore some of the most fascinating construction technologies that you should see. These inventions and techniques are changing the game, pushing the boundaries of what is possible in the world of construction. 1. 3D printing in construction. One of the most revolutionary technologies in construction is 3D printing. This groundbreaking method involves using large-scale printers to create entire structures layer by layer. With 3D printing, it is now possible to construct complex designs with speed and precision, while reducing material waste and labor costs. From houses to bridges, 3D printing is transforming the way we envision and construct buildings, opening up new possibilities for architectural design and construction techniques. The use of 3D printing in construction has numerous benefits. It allows for greater design flexibility, as intricate and customized shapes can be easily produced. Additionally, the precise layering process ensures structural integrity and reduces the risk of errors. The speed of 3D printing enables faster construction timelines, making it particularly useful in disaster relief efforts and urgent housing needs. Moreover, the use of sustainable and recyclable materials in 3D printing contributes to environmentally friendly construction practices. Overall, 3D printing is revolutionizing the construction industry and shaping the future of building. 2. Prefabrication and modular construction. Prefabrication and modular construction are rapidly gaining popularity in the industry. This technique involves constructing components or entire sections of a building in a controlled factory environment, then transporting and assembling them on-site. The benefits of prefabrication and modular construction include reduced construction time, increased quality control, and minimized disruptions to the surrounding environment. In prefabrication, building components such as walls, floors, and even entire rooms are manufactured off-site. This method allows for efficient mass production and streamlines the construction process. It also enhances quality control since the factory environment ensures consistent standards and minimizes weather-related issues. Modular construction takes prefabrication a step further by creating complete modules that can be easily interconnected on-site, resulting in faster assembly and reduced labor costs. Prefabrication and modular construction offer advantages in terms of sustainability as well. The controlled factory environment allows for better waste management and recycling, reducing the environmental impact. Moreover, the ability to reuse and repurpose modules facilitates adaptability and future expansion of buildings. These construction methods are redefining the way we approach building projects, offering efficiency, flexibility, and sustainability. 3. Augmented reality and building information modeling. Augmented reality, AR, and building information modeling, BIM, are transforming the way architects, engineers, and construction professionals visualize and plan projects. Our technology enables real-time overlay of digital information onto the physical environment, providing a virtual representation of the project at hand. This allows stakeholders to visualize the final product, identify potential issues, and make informed decisions during the design and construction phases. BIM, on the other hand, is a digital representation of the physical and functional characteristics of a building. It incorporates detailed information about the project, including 3D models, construction sequencing, material specifications, and cost estimations. BIM allows for better coordination and collaboration among project teams, reducing errors and improving efficiency. By combining AR and BIM, construction professionals can visualize the entire construction process in a virtual environment. This technology facilitates better communication, enhances project coordination, and minimizes costly mistakes. AR and BIM also offer benefits beyond the construction phase. They enable the integration of facility management systems, allowing for efficient operation and maintenance of buildings throughout their life cycle. With AR, maintenance teams can overlay digital information onto the physical structure, making it easier to identify and address issues. BIM provides a centralized database of building information, simplifying facility management tasks such as asset tracking, energy analysis, and space utilization. 4. Drones and robotics in construction. Drones and robotics are revolutionizing various aspects of the construction industry. Drones, equipped with cameras and sensors, can quickly and safely survey construction sites, capturing high-resolution images and generating accurate topographic maps. This data helps in project planning, site analysis, and progress monitoring. Robotic systems, on the other hand, are being used to automate repetitive and labor-intensive tasks in construction. Robotic arms and exoskeletons assist workers in heavy lifting and improve productivity. Autonomous construction vehicles and machinery are being developed to enhance efficiency and safety on construction sites. The use of drones and robotics in construction offers several advantages. They significantly reduce the time and cost required for site surveys and inspections. Drones can access hard-to-reach areas, improving safety and accuracy. Robotics enhance productivity by taking on physically demanding tasks and reducing the risk of injuries. These technologies enable construction companies to work more efficiently, save costs, and enhance overall project outcomes. 5. Sustainable and green building practices. In recent years, there has been a growing emphasis on sustainable and green building practices. These practices aim to minimize the environmental impact of construction, reduce energy consumption, and promote healthier living environments. Energy-efficient building materials, such as insulated concrete forms and advanced insulation systems, help in reducing energy loss and improving thermal comfort. Renewable energy sources, such as solar panels and wind turbines, are integrated into buildings to generate clean energy. Water conservation techniques, including rainwater harvesting and greywater recycling, are implemented to reduce water usage. 6. Self-healing materials. Self-healing materials are a fascinating innovation in construction that holds great promise for enhancing the durability and longevity of structures. These materials have the ability to repair themselves when cracks or damage occur, thus reducing maintenance costs and extending the lifespan of buildings. Self-healing concrete, for example, contains microcapsules of healing agents that are released when cracks form, filling and sealing the damaged areas. This technology has the potential to revolutionize infrastructure development, making structures more resilient and reducing the need for frequent repairs. 7. Advanced monitoring systems. Advanced monitoring systems play a crucial role in ensuring the safety and structural integrity of buildings. These systems utilize sensors and data analytics to monitor various aspects of construction projects, such as structural movement, vibrations, temperature, and moisture levels. Real-time monitoring allows for early detection of potential issues, enabling timely interventions to prevent accidents or structural failures. These systems provide valuable insights into the performance of buildings, enhancing maintenance strategies and optimizing operational efficiency. 8. Virtual reality and simulation. Virtual reality, VR, and simulation technologies are transforming the design and planning phases of construction projects. VR enables stakeholders to experience a virtual walkthrough of the proposed structure, providing a realistic sense of scale and space. This immersive experience allows for better visualization, identification of design flaws, and improved communication among project teams. Simulation tools, on the other hand, help in evaluating construction sequences, identifying potential clashes, and optimizing project schedules. These technologies enhance collaboration, minimize errors, and improve overall project outcomes. 9. Smart building automation. Smart building automation systems are revolutionizing the way buildings are managed and operated. These systems integrate various technologies, including Internet of Things, IoT, devices, sensors, and advanced control systems to optimize energy usage, improve occupant comfort, and streamline maintenance processes. Smart sensors monitor occupancy, lighting levels, temperature, and other parameters, allowing for efficient energy management and personalized comfort settings. Building automation systems also facilitate remote monitoring and control, enabling proactive maintenance and reducing operational costs. 10. Robotics and AI in construction. Robotics and artificial intelligence, AI, are transforming the construction industry by automating tasks, enhancing productivity, and improving safety. Construction robots can perform repetitive or dangerous tasks, such as bricklaying, welding, and demolition, with precision and efficiency. AI algorithms are used for data analysis, predictive modeling, and decision-making, optimizing construction processes and improving project outcomes. These technologies not only reduce human error and enhance efficiency, but also address labor shortages and promote safer working conditions. Construction technologies are rapidly advancing, driving innovation and reshaping the industry. From 3D printing and self-healing materials to advanced monitoring systems and smart building automation, these technologies are revolutionizing how we design, construct, and manage buildings. The integration of virtual reality, robotics, and artificial intelligence is transforming traditional construction practices, making them more efficient, sustainable, and safe. As these technologies continue to evolve, the future of construction holds immense potential for creating sustainable, resilient, and intelligent built environments. By embracing these advancements, we can construct buildings that not only meet the needs of today, but also pave the way for a better and more sustainable future.